Now let us try to understand quickly, not go in detail about the structure of the Earth. Well, we know that the structure of the Earth, which will be having approximately 6,400 kilometer radius. That's what the radius, approximately 6,400. To some places it will be 6,371, some it changes, which will be there. But there are a lot of solid inner core, liquid outer core, and mantle are there. So all these things we are not interested. It's basically with reference to a lot of temperature changes, geological changes. Then we have a lot of mineralogical changes. So there is a lot of minerals are there, a lot of temperature, then a lot of other what we can tell that there is liquids are there, solids are there. Many things may happen inside the part of the Earth. But it is very, very important for engineer to understand that what is the possible movement over the top 100 kilometers, 80 to 100 kilometers, whatever the top movement that we have, that is what the portion of the top, what we are calling it as Asthenosphere. So what is the movement, or what all the movements are possible with reference to Asthenosphere, one has to understand. So what is Asthenosphere? So Asthenosphere is nothing but the top 100, and it is a hot place, and it's a very weak plate, and it is a plastic, through the top 100, the Earth is made of a lot of plates. What we are living in India, we have living in a Eurasia plate. There is an Australia plate is there, like Scotia plate. There is an South American plate and North American plates. All these plates, basically the behavior of the plate is nothing but it can move towards each other. I told about the hypocenter and epicenter. There is a lot of terminologies are there. There is a convergent boundaries, which means that two plates that can move towards each other, or it can move away from each other. That's what divergent and transform boundaries are there. And I told about all the waves that we have the primary waves. It may be a compressive wave or a tensile wave, primary wave. Perpendicular to the primary, whatever the wave that we have, it is called as a shear wave. Then we have the surface waves. And there are a lot of earthquakes which are happening. Just have a glance of the earthquakes. So far what we discussed, first thing is about what is the basic concept of the dynamics that we need to understand. Second thing, what is the science behind it? So science means, I think all you know that it is basically with the Richter scale. We know that the magnitude of the earthquake is constant, intensity of the earthquake is different. So magnitude is nothing but on a Richter scale, Bhuj earthquake, what is magnitude? El Centro earthquake, what is magnitude? California earthquake, what is the magnitude? Likewise, many values are there, whereas the intensity will be different at different places. Even for Bhuj earthquake, intensity at Delhi will be different, intensity at Mumbai will be different, intensity at Bangalore will be different. So with reference to all these earthquakes and the engineering practices that what we are adapting, we are not neglecting anything, but always we know that for a low-rise structure, it's we never worry about what is the horizontal displacement. That is the inertial force we never take into account in case of low-rise buildings. So especially for the low-rise building, always we need to understand that we have to go with the concept of the inertia. So how much ground motion that we have to calculate what is the frequency. And here you can see that when you are having the smaller k, then you can increase your period. Whereas if you are having bigger m, then cycles. And that's what I told you. So the natural period you can calculate. That's what I told you about. We have normally 30 seconds of the shaking. Shaking period will be 30 seconds. So when you are going for 30-story structure, then it has to undergo only 10 cycles of vibration, and it will be good for you. Otherwise, you have to, I think, the lot of damages which may happen with reference to a lot of practices that we have. So the resonance also, I think all you know that when the frequency of the earthquake meets